This is lesson 4-6, absolute value equations and inequalities. Since this happens to be dealing with absolute value, let's refresh our memory a little bit about what absolute value is. Remember, absolute value is the physical distance a number is from 0 on the number line, which means it can never be negative. You cannot go a negative distance. You can go a positive distance in the negative direction, but you cannot go a negative distance. I can't run a negative 5 miles. I can run 5 miles in the wrong direction, can't run a negative 5 miles. You can use the properties of equality to solve an absolute value equation. For example, if we have the absolute value of t minus 2 equals negative 1. If I want to solve this, I simply will take this and do the exact thing I would do as if it didn't have the absolute value symbol in it to begin with. I will add 2 to both sides of this equation. These two 2's cancel out. I get the absolute value of t is equal to 1. Now, what number can I put in for t so that when I take the absolute value of it, it equals 1? Well, the absolute value of 1 is 1, but the absolute value of negative 1 is also 1. Therefore, the answer to this question is t can equal positive and negative 1, because both positive 1 and negative 1, when you take the absolute value of them, will equal 1. If we look at number 2, the first thing we have to do here before we can even take the absolute value is get the absolute value of n all by itself. Since it's multiplied by 3, we will divide by 3. These two 3's cancel out, leaving me with the absolute value of n equals 5. What number can I put in the absolute value symbol that when I take the absolute value of it becomes 5? Well, positive 5 and negative 5, when you take the absolute value, both equal 5. We look at problem number 3. The first thing I have to do here is I have to get rid of the negative 2. So I will add 2 to both sides of my equation. And I get 6 equals 3 times the absolute value of w. So now I need to divide by 3. So I get 2 is equal to the absolute value of w. So therefore, w equals both positive and negative 2, because positive 2, the absolute value is 2, and negative 2, the absolute value is 2. If we look at problem number 4, 2 times the absolute value of n equals negative 15. Most of us will say, let's divide by 2, divide by 2. So we take the absolute value of n is equal to negative 15 halves. What number, when I take its absolute value, can equal negative 15 halves? There is no number that when you take the absolute value of it can equal a negative, because you can't take the absolute value of something and get a negative number. Therefore, there's no solution because absolute value cannot be negative. So this has no solution. So, to sum it all up, absolute value equations, when they're equations, will normally have 2 answers, a positive answer and a negative answer. So when you go to solve these, okay, some absolute value equations, such as absolute value of 2p plus 5 equals 11, have variable expressions within the absolute value symbols. The expressions inside the absolute value symbols can either be positive or negative. To solve these, you must write 2 equations. Unlike right here, where all we had to do was solve for the absolute value, because the only thing in the absolute value in these first examples was the variable itself. There was nothing else inside the absolute value. However, when we get a little further on here, we can see that we have other numbers inside the absolute value symbol. To solve an equation in this form, you solve it so that it equals the positive and it equals the negative. To solve an equation in the form of the absolute value of a equals b, where a represents a variable expression, not just a single variable, and b is greater than 0, solve a equals b and a equals negative b. What does that mean in people terms, not math terms? It means if I have the absolute value of 2p plus 5 equals 11, to solve this I have to set it up twice. I solve the equation all by itself, just written exactly as you see it. 2p plus 5 equals 11. Or, then I write it the other way, 2p plus 5 equals negative 11, because the absolute value of that can equal the positive or the negative. So we have to set it up so that it equals the positive and we have to set it up so that it equals the negative. And then you solve both equations. Now this is a compound equation, just like a compound inequality. Subtract 5 here, so we have 2p equals 6, divide by 2, divide by 2, p equals 3. Over here, we'll subtract 5, 2p equals negative 16, divide by 2, divide by 2, p equals negative 8. So p can equal 3, or p can equal negative 8. Both of those will make a true statement. Let's look at number 2 here. We have the absolute value of 3c minus 6 equals 9. To set this up again, you write it exactly as you see it. 3c minus 6 equals 9, or 3c minus 6 equals negative 9, and solve each inequality, each equation separately. So I will add 6, you get 3c equals 15, divide by 3, c equals 5. Or, if I do this over here, I add 6 to both sides again, you get 3c equals negative 9 plus 6 is negative 3, divide by 3, c equals negative 1. So c can equal 5, or c can equal negative 1. Let's look at these next two problems. The absolute value of 7d equals 14. Here we have both the 7 and the d. It doesn't mean we can just divide by 7. It means we need to set it up separately again. 7d equals 14, or 7d equals negative 14. Solve both equations separately by dividing by 7, and you will have d equals 2, or d equals negative 2. This last equation, negative 5.5 equals t plus 2. We simply can look at this and realize right away that no matter what, if I take the absolute value of something, it cannot equal a negative number. Since I can't have a negative number, the answer to this is no solution. We don't need to solve it, set it up. We don't need to solve it because we cannot have, when we put something in and we take the absolute value of it, it cannot come out negative. Therefore, it can't work, so it's no solution. Now, you can write absolute value inequalities as compound inequalities. Let's take a look at this absolute value. The absolute value of b minus 1 is less than 3. Simply what that means is, no matter what I do, b is going to be less than 3. So I'm going to solve this by the absolute value of b minus 1 is less than 3 represents all numbers whose distance from 1 is less than 3 units. So let's look at this. If I had a number line, here's 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, negative 5. So here we have these two things. b minus 1 is less than 3. So it tells me all numbers whose distance from 1 is less than 3 units. So if I look, here's 1 right here. I have to be less than 3 units. So 1, 2, 3 units. I can be here, or 3 units the other way, 1, 2, 3 units this way. Any number who is less than 3 units, that means I can go that way, and I can go this way. Which means this is an and inequality. A less than becomes an and inequality, doesn't it? Because they're going to end up going toward each other. So this inequality becomes such that b minus 1 is greater than negative 3, but less than 3. Okay? Because it's got to be 3 units away. If I have the absolute value of b minus 1 is greater than 3, that represents all the numbers whose distance from 1 is greater than 3 units. So if I have my lovely number line here, and if I have, here's 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, negative 5. Here's 1 again. So b minus 1 is going to be greater than 3 units. So greater than 3 units, 1, 2, 3 units this way. or 1, 2, 3 units going that way. So it becomes an or statement, doesn't it? So b minus 1 is less than negative 3, or b minus 1 is greater than 3, because that proves it is 3 units or more away. This can be summed up as the following. Solve an inequality in the form of the absolute value of a is less than b, where a is a variable expression and b is greater than 0. You sum it up as the absolute value of a is greater than negative b, but less than b. If you have the absolute value of a is greater than b, where a is a variable expression, is b is greater than 0, you get a is less than negative b, or a is greater than b. This is kind of hard to follow. Think of this. You need to figure out how to set up a variable expression. Okay, so let's say I have the absolute value of x plus 2 is less than 7. It says less than. It becomes what we call an and statement. This is going to be an and inequality, because according to this, it's this one right here. It's the first one. And it says I should set it up so that a is greater than negative b and less than b. The easiest way for me to remember this is this says less than. If I pronounce it less than, I think of than rhymes with and. It makes an and statement. To translate that into this form right here, all I need to do is write it exactly as I see it without the inequality symbols. X plus 2 is less than 7. Take this inequality symbol, put it in the front. Take this number, put it in the front, but make it negative. So that's all you have to do to set up your inequality. So now my inequality looks like this. X plus 2 is less than 7, greater than negative 7. I wrote it just as I saw it. Switched the inequality to the front, switched the number to the front, but made it negative. Now all I need to do is solve this. So if I'm going to solve this, I'm going to subtract 2, subtract 2, subtract 2. Negative 9 is less than x, which is less than 5. So x is between negative 9 and positive 5. Absolute value inequalities are not difficult once you can set them up. Setting them up is the hardest task. So let's look at a couple of examples. We're going to solve and graph. The absolute value of y minus 5 is less than or equal to 2. Less than becomes an and, greater becomes an or. If you can remember, greater is an or, less than is an and. If it's an and statement, you write it just as you see it without the inequality symbol, and then you write the inequality to the front, and you write the number to the front, but make it negative. Now it's all one big long statement. You write it just as you see it without the inequality symbols, move this to the front, and move this to the front and make it the opposite. So now I've got negative 2 is less than or equal to y minus 5, which is less than or equal to 2. So now I will add 5 to all parts of my inequality. Negative 2 plus 5 is 3, is less than or equal to y, because these cancel out, which is less than or equal to 7. So y is between 3 and 7. So I can graph this. Y is greater than or equal to 3, close circle, less than or equal to 7, close circle, line between the two because it's an and statement. And there I have my solution. We look at number 2. The absolute value of w plus 2 is greater than negative 5. It's a greater. It's going to be an or statement. Or statements set up this way. I'm going to write it just as I see it without the absolute value symbol. W plus 2 is greater than negative 5. Or, now I'm going to write it again. This time I'm going to leave the w plus 2, reverse the inequality symbol, so now instead of greater than, it's less than, and reverse the other number. Instead of negative 5, it's positive 5. So now we have w plus 2 is greater than negative 5. Oh, I made a mistake again. Let's go back, erase all of this a second, because I can't have it greater than the negative. Let's pretend this is going to be positive 5 right here. So let's reset this up. So it's going to be greater than positive 5. So the absolute value of W plus 2 is greater than 5. Still sets up the same way, exactly as you see it. W plus 2 is greater than 5. Or, see it again, W plus 2, switch this sign to its opposite, switch this to its opposite. So W plus 2 is less than negative 5. It's a greater, okay? Greater means greater. If you pronounce it incorrectly, you'll remember it's an or statement. So now we set up the or statement, and we can solve it. Subtract 2, W is greater than 3. Or, if I subtract 2, W is less than negative 7. Right? So if I'm going to graph this, W is greater than 3, 1, 2, 3, goes this way. Less than negative 7, 1, 2, 3, 4, 5, 6, 7. It goes that way. Let's look at another two problems. The absolute value of 5t minus 4 is greater than 7. It's a greater problem. Greater. So this is going to be an or. So I'm going to set it up again, just like I see it without the absolute value symbol. So 5t minus 4 is greater than or equal to 7. Or, write it again, 5t minus 4. Switch your inequality symbol and do the opposite. So switch your inequality symbol, make your number negative. Now we solve it. I add 4 to both sides here. 5t is greater than or equal to 11. Divided by 5, divided by 5. T is greater than or equal to 11/5, or 2 1/5. Here I'll add 4, I will add 4. 5t is less than or equal to negative 3. Divide by 5, divide by 5. T is less than or equal to negative 3/5. Again, you can graph these. Just because they're fractions doesn't mean you can't graph them. Greater than or equal to greater than or equal to positive 11/5 is going to be 2 1/5. So 2 1/5 is going to be about right here. Greater than or equal to. Less than or equal to negative 3/5. Negative 3/5 is going to be a little bit over halfway. So it goes that way. And you're done. We look at problem 4. 3 times the absolute value of x plus 4 is greater than 15. Well, before we can set it up as a greater than or less than problem, we have to divide by 3 first. So let's divide both sides of the equation by 3. This cancels with this. We have the absolute value of x plus 4 is greater than 5. It's a greater, so it's an or statement yet again. So we write two inequalities. X plus 4 is greater than 5. Or x plus 4, switch my inequality, which is less than, and do the opposite of my number, negative 5. I subtract 4, x is greater than 1. Or if I subtract 4 here, x is less than negative 9. Oops, that's right. Try that again. So x is greater than 1, goes to the right that way. X is less than negative 9, goes to the left that way. Last problem here. The absolute value of w plus 2 is greater than negative 5. Right, if we were to look at this, can the absolute value of something be negative? No, it cannot be negative. I can't have the absolute value of w plus 2 be greater than negative 5. So when I take the absolute value of something, it can't be negative. So again, this one is no solution. You don't even have to set it up to solve it. It's just no solution. Let's look at a word problem. The ideal diameter of a piston for one type of car is 88.000 millimeters. The actual diameter can vary from the ideal by at most 0.007 millimeters. Find the range of acceptable diameters for the piston. This is a very typical type of problem that you're going to need to know how to set up and solve when dealing with absolute value inequalities. So let's take a look at this. I need to know define my variable. That's the first thing I need to do, as always. And my variable is going to be the range of acceptable diameters. So I'm going to let R equal the range of acceptable diameters. Okay, now, it says that I can have it's like when you build things in a car, you can be off by just a tiny bit, because if you're off by too much, the piston's not going to be able to go up and down in the tube, and it's going to seize, which means it's going to get frozen in the middle, and your car is not going to run. So the ideal diameter is 88.000. We need to know how far off we can be. So it's the difference between the actual and the ideal. Okay, the difference between the actual and ideal is at most 0.007 millimeters. That's what it is saying. Okay? Oh, I shouldn't make, I can see. Nice little line there. So, if I want to figure out the range of acceptable diameters, I'm going to change my variable from R to D. This is diameter. So, the actual diameter, the ideal diameter is 88. This is my ideal diameter. The actual diameter we don't know. Okay? So the actual diameter is D minus the ideal diameter, 88.000, and yes, we need all those zeros. Since the difference can be at most that, it could be off by 0.007 in the positive direction or the negative direction, so this becomes an absolute value. At most means less than or equal to, and the most it can be off is 0.007. So there's our inequality. We've written an absolute value of inequality. That's the first thing we have to do, write the absolute value inequality, and then we have to solve this absolute value inequality. If we're going to solve this absolute value inequality, it's a less than. Okay, less than means it's an and inequality. So I write it exactly as I see it. D minus 88.000 is less than or equal to 0.007. Switch this sign here to the front, going the same direction. Switch the 0.007 to the front will make it negative. So there's my inequality I now need to solve. To solve this, I have to add 88.000 to the middle, add 88.000 to the left, and add 88.007 to the right. Oops, this was right and this was right. These cancel out, leaving me with D is greater than or equal to. Oops, 88.000. There we go. If I take negative 0.007 and add 88 to that, I get 87.993. And if I take 88 and add 0.007 to it, I get 88.007. So the actual diameter can be greater than or equal to 87.993 millimeters, but less than or equal to 88.007 millimeters. So actual diameter can be between 87.993 millimeters and 88.007 millimeters inclusive. Because it could include those distances as well. And that's how to solve absolute value equations and inequalities.